Hello students, welcome back. In this video, we are going to implement the core gameplay mechanic of our game. That mechanic is turrets. Turrets are going to be placed throughout our game world, and they're going to fire projectiles or bullets at our player. The turret is going to be able to figure out exactly where the player is in our game world and fire the projectile directly at their location. This is going to add an element of pressure and gameplay that currently doesn't exist in our game. So let's head to the computer screen and let's dive right in. So I've got vscode.dev open here, and I'm in lesson 3, and our starter file is open. I'm just going to minimize this really quick, and I'm going to open up my actual folder that has these lessons, and let's open this folder and file directly in the browser. So if I run this here, this looks a lot like the previous version of our game. We've got bounded keyboard movement. And if you notice, I've sort of got what maybe looks like it could be a turret living in the top left corner of my screen, but that's a terrible place for it. And right now it's not doing anything, right? It's a completely inactive turret. It's not firing anything. So we got a bit of work to do. We got to reposition this turret. We got to make it look better, and we got to activate it, make it so that it's firing bullets at the player. So let's dive right in. So if I scroll through here in lesson 3 on turret fire, we've got all of our mission checklists. But before we get into the mission checklist, let's look at what we've added here in our gameplay constants in the student edit zone. So what are some things that we can edit about our turrets to change the play of our game? Well, we've got a constant variable here for the size of our turret and the size of our core. We've got a turret fire interval minimum value and turret fire interval maximum value. Our turrets are not all going to fire at the same speed. They're going to be randomized. And so we set the lower bound and the upper bound for their rate of fire. So this turret might fire the fastest, and this turret might fire the slowest. We also have some constants for our projectiles that we're going to create. The size of our projectile, their radius, and the projectile's speed, how fast it's moving. If I scroll just a little bit further down, I've got some colors in our color palettes for our turrets and our projectiles. Feel free to change any of those, right? Change any of those values to fit your own particular game's vision. And then if I scroll down just a little bit more out of the student edit zone, we are creating 2 new variables here. These variables are super important for us here. Our turrets variable and our projectiles variable. Notice right now they're both equal to these square brackets that are empty. There's nothing inside of them. This is a specific data type known as an array. Think of an array like a container that holds a bunch of different stuff. So our turrets array can hold multiple turret objects that we are going to create. So maybe it holds turret 1, turret 2, and turret 3. Oh, that's a 2. There we go, turret 3. So we now have a place to store all of the turrets that we create inside of this array called turrets. Similarly, each one of these individual turrets is going to be firing projectiles. So maybe turret 1 fires a projectile, turret 2, and turret 3 fires a projectile. We can store all of the projectile objects that we create inside of this array. And this is super nice because now if I want to do something to every single one of my turrets, I am just going to focus on this particular value or this variable turrets, which holds all of them inside of this array, this nice container. So this is a nice data structure that we are going to work with and leverage here in this video. So I'm first going to pull up Control F to pull up my mission log here. My mission log for mission 1 tells me we have to spawn the turret at the center of the battlefield, because we said right now I think the turret's being spawned, but it's being spawned way up here in the top left corner. So let's go look at where mission 1 lives. All right. Spawn a turret. This is inside of our reset game to defaults function. This is going to get called right in our setup. If you recall, our setup function, which is a P5 default function, it runs once at the start of our game. We create a canvas, we set our fonts, and then we call this reset game to defaults. It's positioning our turret at 2020. That's not really where we want it, right? I don't know. Let's just change these numbers. Let's make this 220 and 520. So if I refresh the page, well, now my turret is 220 pixels in from the left, 520 pixels down. So it's almost like it's sort of like an X and Y coordinate. Well, what if we make it 0, 0, and I run this and I refresh the page? you can still see the turret right here. It's present. So what that coordinate represents is the center of our turret. That's how we're defining our coordinate system. So I want to spawn it where? In the correct position. I want to spawn it in the center of the battlefield. So the center of our battlefield, if I get rid of 0, horizontally it's going to be width over 2. And in the vertical direction, maybe it's going to be the height of our canvas divided by 2. All right, let's see how this looks. Hey, my turret's sort of in the center, right? That looks like pretty good. It looks centered horizontally. Vertically, what's happening is it's getting centered in the entire canvas, but I want it centered in the entire playable area. Remember, we got this HUD up top. So if you count the lines above, I got 1, 2, 3, 4, 5 lines above, and I got 1, 2, 3, 4, 5, 6 lines below. So that's not necessarily what I want. I want to have it centered in the playable area. So in order to do that, I'm going to add in here my HUD height. And I then want to divide this sum by 2. But you got to be careful. Order of operations, right now, I'm going to divide HUD height by 2 and then add height. I don't want to do that. I want to add these two things together. And so we're going to use parentheses to say, hey, do this addition first and then divide by 2. And now we are positioned in the correct spot. We're centered horizontally and vertically in our playable area. Mission 1, I believe we are done. This is awesome. But before we go into mission 2, I want to look at this spawn turret function. It looks like I'm passing in an X value and a Y value. What are we actually doing with it? So I'm going to just highlight spawn turret by double clicking over it, and then I'll hit Control F. And look at that. I'm automatically searching for spawn turret. And if I hit down, I go to my next instance of it. So there's a function called spawn turret, which takes in an X position and a Y position. And what is it doing? Well, here's that array, turrets. Remember that container that's going to hold all of our turret objects that we create? We're calling the push method on this array. The push method basically says we're going to push something into that array. Our container is going to hold something, and we are going to hold it at the end of the array. See, an array, right? If I just have an array here, turret 1, turret 2, turret 3, each element inside of the array has a position. This is, now here's where it gets kind of crazy. This is the first turret in our array. This is our second turret, and this is our third turret. But this occurs at index 0. This occurs at index or position 1, and this occurs at index or position 2. When we talk about the positions in the array, we start indexing at 0. So what push does is it puts something right at the end of the array. So if I wanted to make another turret and I pushed it, it would go right here at the end. And in this case, that would be at index 3. So the push method is super awesome for adding things into an array. But the question is, what are we adding? Well, if you look here, we're adding a function. A function that we're adding is called generate turret data. And if I just scroll up slightly, that function is right here. It takes in an X, it takes in a Y, and let's see what we do here. We are setting a constant variable called fire interval, and it's going to be randomly chosen from our turret fire interval minimum variable, which was 75, and our turret fire interval max variable, which was 105. So we're randomly going to select from those range of digits the fire interval, and then we are returning a data structure. We're returning an object. So right here, when I say generate turret data, XY, we are getting this object, and it's that object that I've got highlighted that is represented right here that gets pushed into my array. And so this is a turret object. Our turret object has 4 properties. It has an X position, a Y position, a fire interval, and a fire timer. Now, our X and Y, we are passing into this function. So we're setting it. So when I made X width over 2, I'm defining that right here for my turret. When I made the Y, what was it? HUD height plus height over 2, I'm setting it right here. Fire interval and fire timer, this is going to be a way for our turrets to actually shoot out projectiles. So imagine if fire interval were 10, okay? And then fire timer, we are also setting it to 10. And then what we're going to do is every frame of our game, we're going to decrease fire timer by 1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And when it hits 0, that means it's time to fire. We're going to shoot out a projectile or a bullet. And then we'll reset the timer so that we count down from another 10 seconds. So this is sort of the structure that that we're going to use anytime we need to create data structures. We'll have a function that generates the data. We'll have a function that spawns the data. And then if you look right below, we have a function that updates the data. Because remember, in game development, there's three key things that we have to do. We have to define data, update data, and then draw data. All right, so with that out of the way, we have solved mission 1. Let's look at mission number 2. Mission number 2, would you look at that? It's all about drawing the data. We've defined the data. We now have to draw it. So mission 2, we need to draw our turret because right now it just looks like this little teeny yellow square. We want to make it better. So this is all about drawing the turret body and the inner core. We're going to use rectangles in order to do this. Now, if I look, it looks like the inner core is being drawn nicely. We're going to draw a nice little outer core that sits here. There is a problem, however. So our turret, if you remember, we said we're referencing this by the center of the turret. But when we draw a rectangle, the rectangle function needs 4 pieces of information. So if I look right down here, we're doing it for the core, right? We put paint in our paint bucket for the turret core color, and then we're drawing the core. Core X and core Y, those are the X coordinate and Y coordinate of the top left corner of the turret. That's what the rectangle function, the rect function, requires. So right now, I only know the center of the rectangle. So I got to do a little bit of math to give me the left side and the top. And if we look, we're doing that right here. We're saying, hey, turret.x, get its x position, and then subtract the size over 2. That's half of its size. So if the x position, here's the center, and we subtract half of its size, half of its width, boop, that puts us right on the left side. And then we're going to do something similar in the vertical direction. We'll subtract half of its size, which, boop, puts us in the top left corner. And that's what we use here, core X and core Y for our rect function. So we need to do something very similar for its primary body, its main body. So the first thing that I need to do is I'm going to put some paint in my paint bucket. So I'm going to say, let's do fill. And instead of using turret core color, I'm going to use turret body color. And now that the paint is set, let's draw a rectangle. And if you look right up here, hey, I've got some math to get the X and Y values. We're taking the X value and we're subtracting off turret size divided by 2. So that's going to take me from the center of the turret and push me on the left side. And then here is our Y values, which is going to take me from the center and push me to the top. So my upper left-hand corner of the turret's main body is going to be X comma Y. And then I have to pass in the width of the rectangle that I want to draw and the height of the rectangle. Well, we're going to use a square, so they're going to be the same size. And I'm going to use my variable turret size and turret size. Hey, let's refresh the page. Let's see what we got. Look at that beautiful looking turret. That looks awesome. That's super cool. And there's one more cool thing that we're going to discuss before we move on to mission 3. If you look here, we are running all of this code for drawing a turret inside of something called a for loop. A for loop is a wonderful tool when you want to repeat a section of code over and over and over again, a set amount of times. In fact, if you look at the language here, it says for const turret of turrets. Hopefully you remember turrets is our array, our container that is going to hold all of the turret objects that we have. So we might have that array as turret 1, turret 2, and turret 3. The first time our for loop runs and we run this code, turret will be turret number 1. The second time the for loop runs, turret will be turret number 2. The third time our for loop runs, turret will be turret number 3. And it should effectively draw all 3 turrets for us. Let's actually put this to the test. I'm going to go way up to my reset game to defaults, all right, where we are spawning our turret. This was mission 1. So if you want to just search mission 1, it will pop up right here. We spawned 1 turret. Let's spawn a second turret. Let's see if we can add another turret. We're going to push another turret into our array. I'm going to spawn it at width over 2 in the X direction. And then in the Y direction, I'm just going to spawn it at 100 pixels. If I refresh the page, a second turret should appear. And that is the power of for loops. Just like that. We drew 1 turret, we drew a second turret. I could draw another turret. Let's copy this and paste it right down here. And I'll set the Y value to be, I don't know, 500. Where's my other turret? Did I miss it up? Unless it's being drawn right over here. Let's set it to 300, width over 3, or width over 2 and 300. There it is. I was just drawing it too close. So there is another turret. So we can just draw as many turrets as we want. All we got to do is just add them to our array called turrets. So you can see how we're going to use this to build out our game, because one turret is awesome. Multiple turrets, now that's a game. So we're going to be using that. For right now, though, we're only worried about getting one turret to work. So I'm going to delete these 2 lines of code. Oh, but don't delete that curly brackets. We need that. All right, mission 2 is solved. Let's look at mission number 3. We want these turrets to fire. Of course we do. So we are going to be looking in the update turrets function. So every frame of our game, we have to update our turrets. What are we going to update? Well, remember, they have a property called firing timer, their fire timer. We want it to count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And when it hits 0, that's when we are going to actually fire a projectile. So that is something that we have to manually do. And so inside of update turrets, and let's just check, is update turrets actually getting called? Well, where would it get called? In our P5 default draw function. Remember, this is like our main gameplay loop. Everything in here is going to run every frame of the game. Before, we were just updating our player, but now in here, we're also updating our turrets, updating our projectiles, and checking for player projectile collisions. We want to check to see if, hey, did a bullet hit our player? So this is going to run every single frame of our game. And so what we have right here, 4 turret of turrets. We're going to update all of the turrets that we create. So that's kind of cool here. But right now we only have 1, so we only got to worry about 1 of them. But the structure is in place. We're taking the current turret that we are on, and we are accessing its fire timer property. Well, right now, if you look, we're not really decreasing it, because minus equals 0 means decrease it by 0 every frame. Ew, we don't want to do that. Let's decrease it by 1. So it will count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. Let's see if we start firing some turrets. I think I might have closed my, I closed my game out. Silly me. Let me open this back up. There we go. Are we firing? Are we firing? Hey, we're firing. Look at that. Our projectiles are being fired from the exact wrong location. They're being fired from the upper left-hand corner of the screen, but we moved our turret to the center of the screen. So while the system is sort of working, it is not working well. So we need to now begin looking at our projectiles that we're creating. And that's going to be the scope of mission number 4. So mission number 4 is all about projectile movement. And it places us inside of a function called update projectiles. So we are creating all of these projectile objects. Let's just look at the functions that we have here. We have update projectiles, spawn projectiles, and generate projectile data. A very similar structure we had for our turrets, right? We had generate turret data, spawn turret, and update turrets. Now we're generating projectiles. So we have generate projectile data, spawn projectile, and update projectile. If you notice here, when we spawn a projectile, we are passing in a turret. The projectile needs to know what turret it came from. Now, in our update projectiles, if you notice, we're looping again through our array, our container that's holding every single projectile out there, but we're doing it in a different way. This doesn't say like, where was this? If I just scroll up here, it doesn't say, for const turret of turrets. That's sort of nice. This for loop is a little bit messier, and there's a reason why. The reason why is because we are going to want to remove a projectile from this array at some point. And anytime you want to remove something from an array and you're looping over it, you got to be really, really careful how you loop through it. If I have a list or an array and I have projectile 1, projectile 2, projectile 3, and I say for projectile of projectiles, that starts at the front of the list, front of the array, and we loop through it, projectile 1, then projectile 2, then projectile 3. All right, not too bad. But what this notation does, it says for let I equal projectiles, that array, dot length. So how many are in this list? Right now there's 3. And then I'm subtracting 1 from that. So really, this is saying let I equal 2. Why are we subtracting 1? Well, if you remember, when we start indexing the positions of these elements, we start at 0. So the length minus 1, 2, that puts I as the last position here in the list. Then we're saying, hey, let's go until I is, as long as I is greater than or equal to 0, and we're going to decrease I. That's what this means, decrease by 1. So I will be 2, then I will be 1, then I will be 0, and our for loop will stop. The first thing that we're doing here is we're creating a constant variable called projectile. And in order to do that, we are accessing our array, and we're grabbing whatever is at the current value of I. So when I is 2, projectile, we reach into this array, projectile is right here. Then when I is decreased and it becomes 1, we reach into the array, and projectile would be this object. And then when I is 0, we reach into the array and we grab this object. And we can work with it. Now this is super nice because as we delete an object, if I'm working with this object and I need to delete it, I just delete it, it's gone. No problem. And then I gets decreased by 1 value. And so now we're working with this object. And if I need to delete it, no problem, because next time I is going to be 0 and we can work with this object. So it's a nice way to delete things when we are working with arrays and looping over them. So now that I have our projectile, we need to move the projectile using its velocity values. We're going to update our position with each and every frame. If you look, we have the code here already for this a bit. Projectile.x plus equals projectile.vx. So these are properties that our projectile must have. So if we go to the generate projectile data function, let's look at what we're working with. We got lots of missions here. We're going to have to come back, but we are returning a data structure. That data structure represents our projectile, and it has 4 properties: x, y, vx, and vy. So x and y are its position, and Vx and Vy are how fast it is moving in the X direction and the Y direction. Right now, we have it set to 1. I think we're going to probably have to change that. But if you look here, we are using the X velocity to update the X position. And that kind of makes sense. Look, we're using the X velocity to update the X position, but we're not using the Y velocity. We have to add that in here. So we're going to do projectile.y plus equals, well, we're going to look at our projectile, and we are going to target Vy, the Vy property. So we're going to change its vertical position by its vertical velocity. Refresh the page. And where are we? Whoa, look at that. Now we are moving vertically. We are moving horizontally. We have diagonal movement. And since Vx was 1 and Vy was 1, these are moving at the same speed, horizontally and vertically, and we get a nice diagonal line. So that's not too bad. It's still not what we want, though. We still have a little ways to go because really, I want them to originate on the turret, and I want them to be fired at me. So we got a bit of work to do. So let's go to mission number 5. Mission number 5 asks us to calculate the distance to the player. So this is, oh, look here. If I look, it puts us in the generate projectile data function that we looked at. We want to calculate the distance between the turret that is firing our bullet and the player. And we're going to use these variables dx, dy, and length, or len as an abbreviation, to determine how far away the player is. Okay, so why do we need this? Well, if we look, right here I'm on top of the turret. That's a bad place to be. So I'm going to move a distance away in the horizontal direction, and I'm going to move a distance away in the vertical direction. How far away am I from the turret? Well, here's the start of the turret. The shortest distance between 2 points is a straight line. We need to figure out that length. And in order to do that, we are going to do a little bit of math. I hope you're okay with that. I'm okay with it. I hope you're okay. The first thing that we're going to do is we're going to just do a little example problem. We're going to introduce a branch of mathematics known as trigonometry. And in order to do this, I need a nice shape. One of the best shapes for trigonometry is a triangle. So I'm going to draw a triangle. And I'm going to draw a special kind of triangle, something known as a right triangle. A right triangle is a triangle that makes a 90-degree angle. It has a horizontal leg and a vertical leg. And there's a special name for each one of these sides of the triangle. We call this side A, this side B, and this side C. All right, there is a beautiful formula. It is called the Pythagorean theorem that says if you take A and square it, and then add B and square it, that sum will equal C squared. Now, this is known as the Pythagorean theorem. It's super awesome. It's really great. Let's put it into practice. What does this mean? Well, imagine here. Imagine I started here. This is my start. Start. And then I walked we'll say 3 meters to the right. And then I turned and I walked 4 meters forward. This is my end. Okay? How far away am I from where I started? Well, the distance away, is this third leg of my triangle, this C value. This is known as the hypotenuse of the triangle. Hypotenuse. And in order to solve for that, I can use the Pythagorean theorem. I can say, hey, a squared plus b squared is equal to c squared. So 3 meters squared plus 4 meters squared is going to equal c squared. 3 squared, or 3 times 3 is 9. 4 squared, 4 times 4 is 16. And so 9 plus 16 is 25. So you might say, hey, I'm 25 meters away. But that is not true, because what we solve for is c squared, not c. So how do I undo squaring something? Well, I take the square root. So if I take the square root of both sides, the square root and the squared cancel. And the square root of 25 is 5 meters. That tells me if I were to walk 3 meters in the x direction, 4 meters in the y direction, and I stopped, I would be 5 meters away from my object. Awesome. We are going to use this Pythagorean theorem here to determine how far away our player is from the turret. So here's the turret. Here's the player. What we're going to do is we're going to calculate, all right, how far away is the player in the x direction? We'll call that dx. Then we'll say, how far away are we in the y direction? We'll call that dy. And then we can calculate our length right here, shoop, as the hypotenuse of our right triangle. So we can say, using the Pythagorean theorem, dx squared plus dy squared is equal to our length squared. But I don't want the length squared, I want the actual length. So I'm going to take the square root of both sides of dx squared plus dy squared. And that is the relationship that we'll use here to help us in this particular mission. So let's head back to that mission now that we have a solid understanding of the mathematics at play here. Dx is currently equal to 1. Dy is currently equal to 1. Length is currently equal to 1. Those are not the right values. So we got to set those right values. So let's set dx equal to our change in x position. So let's see, we got to figure this out. How are we going to get this change in x? Well, I need, where'd my picture go? There we are. I need the player's x coordinate, and I'm going to subtract the turret's x coordinate. So here's the player x minus the turret x. That's going to give us dx. So let's do player.x, there is its x position, minus turret.x. And then we need dy. Well, dy is going to be very similar. We're going to do, all right, let's just see. That keeps minimizing. The player's y coordinate minus the turret's y coordinate is going to give us our dy. I think that makes sense to me. So player.y minus turret.y. And then we need our length. So this is going to be the square root. And we can take the square root with the square root function of dx squared, 2 multiplication signs for squaring, plus dy squared. And that is the beautiful Pythagorean theorem in action. So now we have the length in the we are away from the turret. So now our program knows, hey, we're a certain distance away from the turret. Now I'm a certain distance away from the turret. Now I'm a certain distance away from the turret. And we can actually use that distance to figure out the direction that our bullets need to fire in, because clearly we are not yet doing that. So let's look at mission number 6. We have to aim at the player. We're going to aim the projectile towards the player using direction values based on the player and the turret's position. So really, this mission has 2 parts to it. We're going to aim based on the player's location and the turret's position. Let's start with the turret's position. When we create a projectile, where do we want to start it? We don't want to start it at x coordinate of 0 and y coordinate of 0. See, we're passing into this a turret that fires it, and that turret has an x position and a y position. So I'm going to create the projectile with its x position set to whatever turret fired it, its x position. Similarly, whatever turret fired it, its y position. That alone is going to make a huge difference. Now our projectiles should spawn right at our turret. Woo! They do. Awesome. But they are not yet aiming at the player. We have to somehow change Vx and Vy. And this, we got to do a little more math. I apologize. Well, not really. I love math. I think math is awesome. So let's go back here to our whiteboard, and I'm going to just come down here and move this a bit. So now I'm going to draw another situation. Here is our Here is our player, or our turret. Here is our player. We know dx. Right, there's dx. We know dy, there's dy, and we know length. Now, if I grab a different pen, I'm going to grab a red pen. Imagine if my player moves, and my player moves over here. Okay, so now my player's here. dx and dy are going to change. Look, dx got smaller. There's dx. dy got bigger. Zoom, there's dy. And length also changed as a matter of that. Now, the difference between those triangles is each triangle has its own angle. I'll call those angles theta, all right? Theta. Now, theta, our angles, can be defined with a couple of nice trig functions. We're going to reference sine and cosine. The sine of theta is equal to the opposite side of the angle divided by the hypotenuse. In our case, if here's my angle, the opposite side is just dy. The hypotenuse is the longest side of our triangle. Remember, we called that our length. The cosine of theta is defined as the adjacent side to our angle divided by our hypotenuse. The adjacent side is the side that's directly beneath the angle. So that's going to be dx over our length. And if you look here, because dx and dy are changing as our player moves, these sine and cosine values are also going to change as these numbers change. As dx gets bigger, see if dx gets bigger right here from this triangle to this triangle, so if I move from this position, down to this position, dx is increasing, which means the numerator right here is increasing. So the cosine of theta is going to get bigger. dy just got smaller. So dy, as we move from these positions, is going to decrease. So the sine of theta is going to get smaller. Now, we're going to use these sine and cosine values to determine exactly where our player is. All right? These ratios, these fractions, are always going to evaluate between 0 and 1. So if it's all like this one right here, if it's all horizontal, this would be 1 and this would be 0. If it were all vertical, this would be 1 and this would be 0. If it was somewhere in between, maybe dy is going to be 0.67 and dx over the length would be 0.32. I don't know. Okay, but we're going to use those decimal values to adjust our velocity in the x direction and in the y direction. So let's look at how we're going to apply this trig math. Right now, we're just setting the speed equal to 1 and 1. I don't like that. Let's first off use projectile speed. We know we have that constant here, projectile speed. Let's set that, projectile speed. All right, and if we run this, what change are we going to get? I think our bullets are just going to move faster, but you see they're still always shooting out in that same direction. So watch what happens if I take one of them and I multiply by a decimal value. Let's just multiply Vx by like 0.3, okay? Now, the direction that we fire is going to change. We were firing in this direction, but now the x velocity, the velocity that points horizontally, just got smaller because I'm multiplying by 0.03. So it's not moving as fast in the horizontal direction while it's still moving super fast in the vertical direction. And then let's see what happens if I change Vy to be like, I don't know, 0.8. All right, let's just see what happens. We're again going to change the direction the bullet flies in. All right, so now it's flying over here. Perfect. So what we need to do is we need to dynamically change those decimals that we're multiplying by so that we can aim the bullet. And the way we're going to do that is with our sine and cosine, right? We're going to take dy over length and represent one of our decimals for our vertical direction and dx divided by our length to represent our horizontal motion. So right here is Vx. Instead of multiplying by any old decimal, let's multiply by dx divided by our length. And here is Vy. Let's get rid of that. And let's multiply, instead of by any old decimal, dy divided by our length. Right now, we have our speed, and we're multiplying by some decimal number between 0 and 1 that is going to set how much velocity do we have in the x direction, how much velocity do we have in the y direction, and that is going to give us bullets that follow the player. So right there, boom, look at that. It's aiming right at me. Right now, dx over length, right? This fraction right here is 1, and this fraction is 0. There is no vertical velocity. If I move to be completely above the turret, now dy divided by length is 1, and dx divided by length is 0. And if I change, we now get decimal values for both of those ratios that are adjusting perfectly to aim at the player. This is awesome. This is super, super cool. All right, let's keep moving. We're making great progress here. Let's see what is next. That was mission number 6. Let's look at mission number 7. Mission number 7 says we got to do some cleanup here. We are going to remove projectiles that leave the arena. If you look right here, that projectile, this projectile that gets fired, it looks like it disappears, but it does not disappear. It still exists, and it's floating across the screen, across the computer, forever and ever and ever. And it is eating up your system resources. Thankfully, not too bad here because this is just a small game. But if this were a big game, you only got so many resources you can use. What we need to do is once a projectile leaves the arena, we have to destroy it. So if we look, we are in update projectiles. We have a for loop which allows for us to remove things from our array. And we're going to do that right here. We have a nice if statement where we are asking a question. We are essentially asking, did the projectile leave the arena? We're checking the left side right here. We're checking the right side right here. We're checking the top up here and the bottom down here. If it leaves any of those spaces, we need to remove the projectile. So how do we remove the projectile? Well, we're going to target the array that the projectiles live in. So that array, if you remember, is called projectiles. And then we're going to use a method. We're not going to use the push method. The push method puts things into the array. And instead, we are going to use the splice method, which is used to remove things from the array. We just have to know what position the bullet is in the array that we want to remove. So you remember we kind of did this thing where we put the array here, and I said projectile 1, projectile 2, projectile 3, and we said, hey, these are at positions 0, 1, and 2. Well, we need to know what index we want to remove from. So if I did splice and I said 0, it would remove this one. If I did splice and I said 2, it would remove this one. Thankfully, we have this little variable here, I, which we were using to access the correct projectile by its position. We're going to use I again down here. So we are going to splice, not a number. We're not going to say 0 or 1 or 2. Get out of here. We're going to use that variable I. And then we need a second piece of information here for the splice method, and that is how many objects we want to remove starting at that location. I only want to remove 1. So imagine if I said, hey, start at index 0 and remove 2 objects, it would remove 0 and 1, these 2 right here. But I don't want to do that. I just want to get rid of the 1 projectile that has left the screen. So just like that, you are not going to see any visual change. But boy, do I promise you, the back end, your computer is thanking you, because now the moment that bullet leaves the screen, it is being removed from memory and those resources are filled up. We are so close to a fantastic lesson here on our full core mechanic. The last thing we got to do is mission 8, which is all about collision detection. It says, hey, we got to detect a collision between the player and our projectiles, and we're going to trigger the lose state when a hit occurs. All right, so what do we got here? Well, we're looping over every projectile. We've got a dx, a dy. Hey, I'm familiar with those. We looked at those earlier. It's how far away the player is from the bullet, how far the player is from the bullet in both the horizontal and vertical direction. And then we got this new variable called hit zone. I'm not really sure what hit zone is, but it looks like we're taking the player's radius and adding the projectile's radius. And right now we have a question. It says if false. Bad news for you. This question will never be true. So the stuff that's inside these curly brackets is never going to get executed. We want to put a question in here that when a condition is true, we set our current game mode to lose. Basically, when we lose the game. So what is this condition going to be? Good news, bad news. It depends. Do you like math? We got to do just a little bit more math. So I'm going to get my tablet here and we're going to draw another picture. All right, so let's start by drawing a player. So here's my player, zoop. And I'm going to draw a bullet. So here's my bullet, zoop, right here. Okay, so player and bullet. Just like before, we have a dx, zoop, there's our dx. And we have a dy. All right, so there's our dy. And then we've got this length between them. So this is like the distance between our player and our bullet, length. So as length gets smaller, if length is very small, I'll put that in quotations. If it is very small, we have been hit, right? That means we've been hit, right? As the bullet gets closer and closer and closer, length gets smaller and smaller and smaller. How do we know when we've finally been hit? Where is, like right here, if the bullet's here and I'm here, I have not yet been hit. Well, let's zoom in. Here's my player. Here is my bullet. zoop, bullet. If you remember, the bullet has a radius. I'll call it R1. The player has a radius, R2. And if I add those distances up, the player radius plus the bullet radius, or the projectile radius, I should call it, that is what I'm referring to as the hit zone. All right, so if the length of the distance between the bullet and the player is less than the hit zone, we have not yet been hit. Hey, that's awesome, right? So if len is less than, as long as len is greater than our hit zone, we have not been hit. No hit. But what happens if the length is less than or equal to our hit zone? Well, then we have been hit. All right, that means we've been hit, right? The bullet has passed into the player. Game over. So how do we get these values? Well, I'm going to switch a color here so we can look at the math in a bit of a different color. We know we can calculate the length here as using the Pythagorean theorem. The length is going to be dx squared plus dy squared equals length squared. Now, I could take the square root of both sides. I could say, all right, let me take the square root of this side and the square root of this side and say, okay, the length is equal to dx squared plus dy squared, the square root of that. And I could then come over here and say, okay, as long as the length is less than the hit zone, so as long as the square root of dx squared plus dy squared is less than or equal to hit zone, if that happens, then it's game over. Game over. We have died. And that is a valid way to do this. But one of the things that's going to happen here is taking the square root is sort of, maybe I'll just say it's like computationally intense. And really, there's no need to do it. I can square both sides. So if I square this side, the square root goes away, and I can just say, hey, let's take the hit zone squared. And now, what we do to one side of our equation, we did to the other side of the equation. This is also true. And so this is going to be our game over condition right here. If dx squared plus dy squared is less than or equal to our hit zone squared, if that happens, the bullet has crossed into the player, and it is now game over. So let's code that question. I mean, we got dx, we got dy, we've got our hit zone. All we got to do is plug in the math for our question. Easy peas, lemon squeeze. Dx squared plus dy squared. That's the distance between the bullet and the player squared. If that is less than or equal to hit zone, okay, that's the sum of the player's radius and the projectile's radius. And I'm going to square it so I don't have to take that nasty square root. If that happens, then we are going to trigger the lose state. We have been hit by a projectile. Ladies and gentlemen, I think this lesson is complete. Let's test out our game. So here we go. I can move around. I can dodge my bullets that are being fired directly at me. And then when I get hit, an immediate game over. This works out awesome. And then I can try it again. We now actually have some gameplay. It's still kind of boring, I'll give it that, but we have it and it works. All right, and I got hit again. Whew, an intense lesson where we finally had to use some math that maybe you've seen in school. You might have sat in class saying, when am I ever going to need to know this? Why do I care about the Pythagorean theorem? Well, now you know, right? You might need to dodge bullets that are flying at you from a tower. You got to calculate the hypotenuse of a right triangle on the fly. I think this is a really good place to stop. Our game is coming together in a really nice form. We've got lots of different systems that are working. We've got input systems for player movement. We have what do we got? Projectile systems and turret systems. Our core gameplay mechanics all working together, and we're just going to keep building on this to make our game better, better, and better. And we'll start that in our next video. I'll see you then.